Welcome to our exploration of two fundamental concepts in physics, time and space-time. You know, the kind of stuff that makes you scratch your head and wonder about the universe and your place in it. We often talk about time as if it's separate from everything else, a sort of cosmic clock ticking away in the background. But what if I told you that time is just one piece of a much grander cosmic tapestry? Let's dive into what sets these two apart and why understanding them is crucial for grasping the universe's mysteries. We'll journey from the familiar ticking clock on your wall to the mind-bending realm of Einstein's relativity, where time and space intertwine in a cosmic dance. Get ready to have your mind blown wide open. Let's start with a thought experiment. Imagine time as a straight line. You can move forward along this line, experiencing events in a sequence, but you can't go backward and you can't jump ahead. This is the essence of time as we traditionally understand it, a single dimension. Now picture our universe, not just as a vast expanse of stars and galaxies, but as a four-dimensional fabric. This fabric is space-time, a concept where time is interwoven with the three dimensions of space, length, width, and height. Think of it like this: you can move forward and backward, left and right, up and down. Those are your three spatial dimensions. But you're also moving through time, that fourth dimension, constantly traveling from the past to the present to the future. This fourth dimension, time, isn't just a straight line anymore. It's woven into the very fabric of space, creating a dynamic and interconnected cosmic grid. This is space-time, a four-dimensional stage where the grand play of the universe unfolds. This concept of space-time might seem strange at first, but it's crucial for understanding the universe on a grand scale. It's like trying to understand a painting by only looking at one brushstroke. To truly grasp the masterpiece, you need to see the whole picture, all the colors, all the dimensions. And that's what space-time allows us to do, to see the universe in its full four-dimensional glory. We often think of time as something absolute, ticking away at a constant rate for everyone, everywhere, but what if I told you that's not entirely true? This is where the distinction between time and space-time becomes even more fascinating. See, in our everyday lives we can get away with thinking of time as separate from space. We set our alarms, schedule meetings, and measure the duration of events without worrying about the curvature of space-time. But when we venture into the realm of the very fast or the very massive, like black holes or the speed of light, our everyday understanding of time crumbles. Imagine two identical clocks, one here on Earth and the other aboard a spaceship zipping through space at near light speed. According to Einstein's theory of relativity, these two clocks wouldn't tick at the same rate. The clock on the spaceship would tick slightly slower due to the effects of time dilation. It's as if time itself slows down for objects in motion. This mind-bending concept highlights how time, as part of space-time, isn't absolute but relative. It's woven into the fabric of space, and just like that fabric can be stretched and warped, so too can time be affected by gravity and motion. Think of a bowling ball placed on a trampoline. The ball represents a massive object, like a star, and the trampoline represents space-time. The ball causes the trampoline to sag, creating a curvature. Now imagine rolling a marble across the trampoline. Its path will curve as it approaches the bowling ball, drawn in by the dip in the fabric. This is analogous to how gravity affects space-time. Massive objects warp the fabric of space-time, and this warping influences the motion of objects around them. It's not that the objects are being pulled by a force, but rather that they're following the curves in space-time created by massive objects. This is how Einstein redefined gravity. Chapter 3. From Newton to Einstein. Theories of time and space-time. For centuries, the prevailing view of the universe was shaped by Isaac Newton's laws of motion and gravity. Newton saw time as absolute and unchanging, a cosmic metronome ticking away at a constant rate throughout the universe. Space, too, was a fixed and rigid stage on which the celestial ballet played out. Then came along Albert Einstein, who, with his revolutionary theory of relativity, shattered these long-held notions. Einstein proposed that time and space were not separate entities, but were inextricably linked, forming a unified four-dimensional fabric called space-time. This new understanding of time and space had profound implications for our understanding of the cosmos. It explained the anomalous precession of Mercury's orbit, a puzzle that had baffled astronomers for years, and predicted the bending of starlight around massive objects, a phenomenon known as gravitational lensing, later confirmed by observations. Einstein's theory of relativity didn't just refine our understanding of gravity, it fundamentally changed how we perceive the universe itself. It revealed a cosmos that was far more dynamic and interconnected than we had ever imagined. A universe where time and space could be stretched, compressed, and warped by the presence of matter and energy. Think about the implications for a second. Black holes, those cosmic monsters that warp space-time so severely that not even light can escape, become not just bizarre theoretical constructs, but inevitable consequences of Einstein's equations. The expansion of the universe itself, a discovery that revolutionized cosmology, can only be understood within the framework of space-time. Einstein's theories weren't just about abstract equations, they were about revealing the hidden connections that weave together the fabric of our universe. And at the heart of it all lies space-time, the grand stage where the cosmic drama unfolds. By understanding the differences between time and space-time, we can better appreciate the complexities of our universe. We move from a simplistic view of a clock ticking away to a dynamic interconnected cosmos where time and space are woven together. We see how gravity shapes the cosmos and how our perception of time itself is relative. This exploration is just the tip of the cosmic iceberg. There's so much more to learn and discover about time, space-time, and the universe we inhabit. So, the next time you look up at the night sky, remember that you're not just looking at distant stars and galaxies, but at the intricate workings of space-time.